Okay.
Okay, so you can start whenever you want.
So,
Go, folks.
so what I have here, this is my main robotic telescope. It's called a Stellina by Ennis. Which it's pretty good. That's the Orion Nebula, which I took with it. The hang on. So the field of view of this, it's 400 millimeter lens, but it's a very it's a chromatic lens, which means it corrects for all three colors. It's low density. It's basically an expensive lens, and it has a field of view of about 1 degree by 0.7 degrees. So it's useful for taking pictures of something like the Orion Nebula, but it also has fairly high resolution. So the Whirlpool Galaxy, which I also took with this, that has a resolution of it. That's only 13 by 11.5 minutes, which is pretty small. You wouldn't really, I don't think you'd see very much in an optical telescope unless you had quite a lot of magnification. But the nice thing about this is basically I just sort of log on to it and tell it to look at the Whirlpool Galaxy, and it orientates itself by doing a placeholder. It looks at stars and works out where it is, and then it'll just point to the Whirlpool Galaxy and start stacking, live stacking, which means it takes multiple frames every 10 seconds. It takes a picture and then it combines them all. And because the signal, the noise is random, the signal is not. The signal builds up, so you get a stronger and stronger image. So it's sort of equivalent to having a larger telescope in space, except you're sort of expanding in time and getting a long exposure image. And this will do live stacking, so it builds up the picture in real time, but it also saves the raw images to a USB drive, which is in here. So I can take those home, stack them, process them, do all the kind of fancy tricks, deconvolution, which is basically reversing the any errors and spread errors in the lens. Play around with the colors a bit to enhance the colors, which I usually do using Infinity. I used to use Photoshop, but I find that Infinity Photo, which is $1,900 or something, and compared to $20 a month Photoshop, seems to work pretty well.
How much is Affinity? How much is it?
It's about 90, but it's a one-off payment,
Yep.
so 90, something around 90, something like that.
Yeah.
It's not hugely expensive. I mean, Photoshop adds up, if you're not, depending on how much you use it.
Question here, just so you're saying, looking at those pictures, that those are both to the same scale?
No, I've zoomed that one out.
Oh, okay.
It's the same sensor.
Same sensor, but one has been
But I've zoomed it,
expanded.
yeah. Expanded it.
Okay.
Yeah.
Okay.
So I have a question. So is that outside looking at the sky, or is that in your house using a connection on the?
Well, I
internet
could be
with
sitting in my
somebody
house.
else?
I'm usually sitting in the warm room.
He's sitting in the house, the bells outside.
Okay.
So, and I can put that on one of the pads, sit in the warm room and watch the image come up. And it's something fairly bright, like the Orion Nebula, which is magnitude of 4+4. That's reasonably bright. It starts appearing within a minute or so. It comes really quickly. And so, but most of these, they go on for around 30 minutes of exposure. Each exposure is 10 seconds, but the telescope rejects the frames unless they sort of meet a certain standard. So 30 seconds, 30 minutes of exposure takes quite a bit more than 30 minutes in real time. It's more like an hour or more. So that's this gadget. So it's a reasonably good quality, I think. For these are some other objects. These are really small, and again they're expanded. So there's still reasonable resolution. The Crab Nebula is the remains of a supernova from 10 something or other, 10 in the 11th century. 1054. 1054. That's before the Battle of Hastings.
1066.
That's it, just before, yeah. Yeah, well, someone asked me how long I've been in England. I said since 1066, because my relatives actually came over with
Lawrence couldn't get handed on him. Jose Maltos, 4 for 4, longest of 49, and that's what this one is as well. 49 yards right.
Gary? Yeah, okay.
Can we move?
Yeah, Gary is
Okay.
is also listening.
Okay. So that's the Lena. And those are pretty small. I can't these are all actually quite small images. I can't let's see. I'll move that a bit. So that's I can't then I have to look up to see how much the dumbbell is well there's some I've got to look at the sombrero, say.
Richard,
Hmm?
do you zoom in when you're setting up the image
Oh, what?
to get like, well, these are, you zoomed in on.
Oh no, I did after.
Oh, you do it after.
Oh yeah. Because that one,
So what was the question for?
do I zoom in when I'm
Yeah, you can't zoom in, right, with this scope.
no,
You can only
no,
do
it's
post
fixed.
after it's taken.
Yeah. So yeah, that's so the sombrero, that is basically 8 by 5 half minutes. So it's pretty small. The sombrero, which is
8 by 5.
yeah. And then that's the horse head, which is heavily zoomed. You can see it's actually starting to lose resolution, but I thought it was still quite a good illustration of the horse head. And there's all the Iris Nebula, which is a reflection nebula. You can definitely see it's a sort of reflection. So that's oops. What is this?
When you, in post-processing, when you zoom in on things, how do you combat losing of the data quality? When you zoom-
Well, I mean, you can't. I don't use the JPEG image. I use the TIFF file.
Yeah,
So that's fairly high res. It's 6,000 by whatever. Can't remember, but it's is it 12 megapixels? I think. I mean, it's still fairly. There's a lot of data there.
okay.
So, and I sort of play around with it a bit, denoise it, and I just kind of play around with the high pass filter to sharpen it a bit, deconvolution, deconvolve it. There's a program I have called AstroSurface, which is good for deconvolution.
What does deconvolution do for you?
It reverses the point spread function, so that if you imagine a dot, a star,
yeah,
when you see it on an image, it'll have a profile, which is called a point spread function. Okay. So mathematically, if you know the function, you can reverse it.
And then with a smaller dot.
Yes,
effectively.
and then so it looks sharper.
Okay.
But then if you don't know exactly what the point spread function of the lens is, but you can guess and try different functions and improve it. So
okay.
So there's again actually Stellina. Now, Andromeda Galaxy.
Step back into the camera.
That was no, that was actually because it's only the central part of the Andromeda Galaxy. That was actually no, that was taken with the dwarf. This one. I'll come to that in a minute. The Milky Way was taken just with an ordinary SLR, DSLR. I got a 13 to 85 millimeter lens. No, 16 to 85 millimeter lens. I had it on 16 millimeters. And I took 15 exposures and stacked them. And if you, I don't know if you're aware, but there is a sort of rule of thumb formula for working out how long you can take an image of the sky without getting star trails. And it's approximately the 500 divided by the focal length in millimeters. If it's full frame format, and if it's a DX format, you have to put another factor of 1.4. So so basically, I get it's about I get for my camera I get about 20 seconds of exposure before I get star trails. So as I usually take about 15 exposures, 20 seconds each, and then stack them. But if you want, and that's usually about 1600 ASA, or maybe 3200. But then you can also get one of these, which is a tracker you can put on your camera, and if you color align it, then you're going to talk about, then you can take your camera, track sky, and take much longer exposure. That's that's the Stellina. Sorry, that's the camera. Just an ordinary DSLR.
Ordinary DSLR.
Digital single lens reflex.
What does it look like?
Like an ordinary camera. just a regular camera.
And you said 16 millimeter lens. Would that be like
It's a wide angle.
Super wide
It's physically about that size.
Yeah. Okay.
I didn't bring my camera with me. It's just a regular camera, a Nikon 7200 actually did it. So this is more of the images that you can get with Stellina. Mostly sort of 30 seconds worth of exposure, but sort of kind of roughly 10 seconds or so. I mean, it is 10 seconds, but roughly 30 minutes worth, plus or minus. Some of them might put longer because it just depends. You can watch it building up on your phone and see when it looks as if you have a decent image. But those are all pretty small objects, and it's sort of detail really you could only see in a photograph. You can't really see it with the naked eye, just because your eye is not sensitive enough to the color. Huh? With what? No, that's Stellina. Then okay, so these are some wide angle shots of the sky. These are the inserts are taken with sorry, the one on the left, the Pinwheel Galaxy, that's an insert, and then the wide angle shot, I just get the SLR and just point it, look to see where the telescope's pointing and point it roughly in the same direction, and take a wide angle shot and then figure out where in the sky the object is that I'm photographing. So it's just where I put the arrow, and then I put the other major stars there of the Big Dipper and the Kite, just to sort of kind of give an idea of where in the sky the object is. that one is Selena, because there's the butterfly, they're very small objects again. And then what I usually do is I use Sky Safari Pro, but you can use Solarium or something similar. And I find it's remarkable how good the sort of human eye is at pattern matching. You can, I look at the sky in the camera, and then look at the sky. I set the date and time in Sky Safari Pro, which is one I use, but it's similar to Solarium. And I find it's quite easy to match the patterns and then work out where all the stars are, and then eventually work out where the object is that I just photographed. And this is another one, again, a wide angle shot, 16mm lens, about 15 exposures of 20 seconds each, about 3200 ASA. And then the Heart Nebula was with Selena, and the Andromeda Galaxy was with the Dwarf. And then I did a similar thing with the Ring Nebula there. Got the Summer Triangle, Vega, and then you can see from the arrow, we got Cygnus, Swan, and then see the arrow and see where it is in the sky. Again, it's the same technique. I just point the robotic telescope and then I eye up my camera and point it in the same general direction, and then go back and figure out exactly where in the sky the object is. Then I got well, these are just more shots with Selena. They're quite colorful. You wouldn't see those colorful colors with the human eye. Now this the Eta Carinae Nebula is in the southern hemisphere. It's not invisible in the northern hemisphere. And I took that with a dwarf. And the advantage of this, as you can see, is it's actually, you don't really even need the whole tripod. It's really quite compact. So I just took that as carry-on the plane, and get to Australia and start taking photographs without, I mean, this would be a bit bulky. It weighs about 20 pounds.
Richard, I have a question. I noticed online on the Seastar site, a lot of people are using a wedge with these, but.
Oh, you can, yeah.
But why?
I
mean, it sets up on a tripod, they send a tripod.
Yeah, because you get the netting.
Yeah.
This will track digitally,
Yeah.
and all as. But you'll get vignetting at the edges.
Oh.
So if you set it up as if it's put as like an equatorial mount, then you avoid that. So it actually gets. But I just clip the edges.
Yeah, that's good. Thanks.
The Veil Nebula again. You can see the colors. You wouldn't see those in an optical telescope. That was with this one. Well, then there's a couple more with Selena. And then there's another one here again. It's the Omega Nebula, which I took, and then I took again the wide angle shot, 16mm with my DSLR Nikon. And again, did the same thing. I stacked it and deconvolved it, and then just put in some key stars so we could see where it is in the sky, which is quite interesting. And then you can see the teapot asterism. And that one was with Selena. That was the supernova in 2023. that I was able to find quite easily. I just typed in the right ascension and declination, and it just found it immediately. Well, that's my lazy.
Was that picture taken at the airport?
Yes.
I guess they're gonna have to do some tree work.
Well, that was 2 years ago, though. So
It's gonna be worse. Okay, yeah, that tree's.
Okay, so now we've got, well, the one on the right, the large magellanic cloud, that is huge. That again is only visible in the southern hemisphere. I took that with the dwarf. And the dwarf, that's what's it by, it's roughly this is the dwarf first. Yeah, it's about 3 by 2 degrees, roughly, the field of view of the dwarf. So, but that was a tough one because it was taken in Sydney and there's quite a lot of light pollution, so I had to get rid of that. Now we come on to planets. So planets are quite different as a type of object from deep sky objects. Deep sky objects generally are diffuse, very dim, and quite large in terms of the field of view. Planets are quite the opposite. They're small and very bright. Jupiter, well, it varies depending on where it is, but it's roughly about 30 arc seconds or half a minute in size. So for that, I use this gadget, which goes on my Celestron C8, or it could be, I mean, any optical telescope. And it's basically just a high-speed sensor. There's no lens in it. The telescope is the lens. And it takes about, it just plugs into the computer and it takes about 90 frames a second. With each frame being a few milliseconds, sort of kind of 10, 20 milliseconds or something.
What's it named? What's it called?
It's called a Mars C Player 1 IMX planetary camera.
How tricky is it
What a catchy name.
the focus to get perfect focus?
Well,
with
you
that?
go, this is just a sensor. So you have to do a telescope. So you have to,
Make
so you
sure-
can look at the image in real time
Yeah, okay, and then focus it.
and focus it.
Yeah, okay.
So, and to look at the image, well, I can show you in a minute. I
Yeah.
use a program called SharpCap, which controls the camera. And it's, again, it's a subscription, but it's not huge. I think it's something like $10 a year. It's more of an annoyance than anything. But this will go on basically any telescope. I mean, that's 2-inch diameter. It also has a 1 1/4 nose piece as well. So you
Would
can
it go on the solar scope?
yeah, it does. That's I use it. The color photos I take on my solar scope, I take with this.
If I had that with a double stack on, which is fairly dark, with the double stack, that would probably work well, wouldn't it?
Well, it would. The other thing about this is it's a color camera, and I use it as kind of a little bit of a cheat because the solar scope is monochromatic, so you don't need a color camera. You're better off with a higher resolution mono camera, but it doesn't look so impressive if you're in a booth or something. You've got visitors, and and if I use this and turn up the saturation, what happens is the sun goes white, but the solar flares become visible, but they're of course red because they're hydrogen alpha.
Was that what you were using up at the
Yeah.
company?
So it looks
Okay.
it looks like you've got flames coming out of
Yeah,
the sun. And if I use a mono camera, which actually probably gives more detail, and certainly if you're looking at sunspots, it gives more detail. it just doesn't look as exciting. It's just, you know, black and white, but the details there, because it's the mono is higher resolution. You don't need, this is a Bayesian matrix, you know, you have, but anyway, and these are around, I don't know, $400 or something. But it's just basically a sensor. It's not, I mean, it's not really a camera in the true sense. The camera is the combination of the telescope and the lens.
You just use a USB connection?
Yes, it's USB.
Yeah.
And actually this, which I haven't used very much since I got out, but this is a high resolution, this is a cool camera. And this could go on a main scope like the observatory scope. And if you're prepared to sort of spend the night up, you know, freezing cold, you should be able to get some really good images of that. This is the ZWO, which was the one you were talking about the other day. Yeah.
Just if you could just go back to the Jupiter one, I think although Jupiter is pretty bright, that typically when you're looking through an optical telescope. When you're looking through an optical telescope, the atmosphere is you know giving so much distortion that you just barely see, kind of like once in a while it seems that Jupiter will suddenly give you lines and stuff like that. But when you do a photography, like
well, that's it.
high-speed
You talk about
photography,
lucky imaging.
yeah,
You're
you
getting
can
that
throw
once in a
out all
while. If you take 90 frames, I take 3,000 frames to get that,
Yeah.
roughly. Or maybe even 5,000. And so
what percentage do you reject?
80.
What?
It's
80%?
it's settable, but I have it set at accept best 20%,
Yeah.
which is just arbitrary. But
Yeah.
so and then you can slide along, and then you can choose a good frame, the best one, and then you say take the best, take the best 20% frames and stack them. And that of course is superimposed on an image I took with my camera. So the rest of it's taken with with my Celestron. And actually my SLR, I didn't use that. So just to get the moons. Because I mean that white circle is Jupiter, but at a different scale. Because otherwise I wouldn't see the moons. So I put the close-up of Jupiter in the same picture as one that showed Jupiter overexposed, which it had to be in order to see the moons.
Yeah.
I got a smartphones. And what they tell us going in is don't even bother trying to shoot planets with these telescopes.
Yeah, they're not designed for it.
They're deep sky imaging.
So Jupiter, I just said it's 30 seconds, that's half a minute. Selena is 1 by 0.7. So I mean 60 minutes, so that's it's 3,600 seconds. So we're talking about 30 seconds. So it's only a few pixels on Selena. So that was oh, there was just some, hang on. And then on the back, I've taken a picture of each planet. They're not to scale, but I just put them all in a line. But they're all, but actually, having said that, Mercury was taken with an SLR. What was it? No, it was taken with my Celestron. So, up to Saturn was taken with my Celestron, but Uranus and Neptune, which I'd never have found, I took with the Selena. But there's no detail, but at least you can see that they're round and you can see the color roughly. You can see Uranus is sort of greenish and Neptune is sort of bluish. But that's that. And then just one final piece of equipment. this is actually from my radio telescope. Not this antenna. It needs a huge satellite dish. But this is a software-defined radio, and it goes from essentially 0 to 2 gigahertz. So I can plug the dish on there, connect that to the computer, and I can see the whole spectrum of, well, I mean, a range that I choose. So if I'm looking at the hydrogen line, which is what I'm working on, I can set it to around 1.4 gigahertz, and then you can see the peaks. And if you're really good and you know what you're doing, you can monitor the movement, the Doppler shift of the peaks as the galaxy rotates, and that's how they calculate the rate of rotation of the galaxy and all kinds of information you can get out of the radio telescope. So I think that's pretty much.
I'm gonna get you that dish yet, I haven't had it.
Yeah, yeah, that would be
It's
good,
big,
because that will go into this.
yeah, it's just I've been so busy.
But this is, so it's the whole radio is in software, so it should basically just digitizes the input and then it processes them.
Question, you said that you use that to determine the rate of a galaxy, you mean this galaxy
Yeah, the
or
Milky
or
Way.
a number one?
The Milky Way.
Just the Milky Way?
Well, I think, I mean, they do all kinds of things with the hydrogen line, and I'm not
Okay,
an expert in radio astronomy, but I mean, because they've got the Chime facility and.
right, but that's not an
huge.
amateur, that's not an
Not
amateur
an
setup,
amateur,
right?
no.
Yeah, what I was thinking was with
But
this one here.
No, I think, I mean, right now I'm just trying to contend with looking at the sun or listening to the sun.
Okay,
But I think with a dish, I should be able to pick up the galactic signal as it crosses the meridian. I should be able to, according to the literature, but I haven't tried it yet.
okay.
So, well, that's, yeah. So any questions?
How many books have you printed of that?
Oh, yes, one. I just did it. It was actually Richard's suggestion of the hatchery. I had all the photos laid out, and then I thought, well, I never look at them because they're just in my computer. So I made it into a book.
It's quite nice.
Yeah.